So today I want to talk about a concept that comes up all the time in mathematics, and that is absolute value. And the idea of absolute value is to take any number, right, call it x, and we write these straight bars around it. And this is the absolute value of x. And what does that mean? Well, let me give you a couple of examples before I give you the full definition, but the examples illustrate the entire concept. Take a number like -2, put it in absolute value. What do you get? 2. It removes the negative sign. Take a number like -11.5, put it in absolute value. What do you get? You get 11.5. So the absolute value signs are basically removing the negative. If you start with a number like 4, which is already positive, then the absolute value is just 4. So for positive numbers or 0, it does nothing, and for negative numbers, it removes the negative sign. So what that means is that we can define the absolute value of x as follows. It's a case definition because it does two different things depending on whether the number is greater than or equal to 0 or less than 0. If x is greater than or equal to 0, it does nothing to it. It leaves it the same. Whereas if x is less than 0, then it changes it into the corresponding positive number. So -2 becomes 2, -11.5 becomes 11.5, and what that means, to get rid of a negative, we sort of paradoxically add a negative, so it looks like this. So the absolute value of x is just x if x is greater than or equal to 0, and it's -x if x is less than 0. And the confusing thing about this definition is just exactly that. It looks like we're adding a negative in, but since we're only doing that in case the number was already less than 0, this negative actually makes it positive. So the absolute value is always giving us a positive number. If we were to graph it, here's x, here's y, and we want to graph y equals the absolute value of x. So this is like graphing a function like we did before. If x is 0 or positive, it's just giving us back the exact same number. So 1 maps to 1, and 2 maps to 2, and 3 maps to 3, and so on. And if x is negative, -1 becomes 1. -2 becomes 2. -3 becomes 3. So it ends up looking like this. So the graph of the absolute value function has this kind of sharp point here, which is where the case definition changes. And it's basically just taking any number and forcing it to be positive, which means doing nothing if it's already positive, and multiplying it by -1 if it was negative. And the last thing that I want to say about absolute value is that it's often used to talk about distance. So let me show you why. Let's take a number line, 0, 1, 2, 3, 4, -1, -2, -3. If I want to talk about the distance between two numbers, let's take an example like the distance between -2 and 3. How far apart are these? Well, we could sort of count 1, 2, 3, 4, 5. So I might write the distance between -2 and 3. This is just a new function I'm making up on the spot. The distance between these two numbers equals 5, just by observing how far apart they are. Okay, and you can see that what I really did here to figure out the distance between these two numbers is I took the bigger one, 3, and I subtracted the smaller one, -2. That gives me 5. Okay, that's what a difference does. When you subtract something, you're saying 3 minus -2 is like saying how much do I have to add to -2 to get up to 3. And that's why I get the distance between them. So then in general we might think the distance between x and y is what? Well, the question is, should it be x minus y, or should it be y minus x. Which one is bigger? Right? Which of x and y is bigger? I'm supposed to subtract the bigger one from the smaller one. Because if I look at, do this over here, if I look at 3 and negative 2 again, when I do 3 minus negative 2, I got my answer of 5. But if instead I did negative 2 minus 3, I would get the negative of my answer, negative 5. So the point is that the difference between x minus y and y minus x, they're equal if I just multiply 1 by negative 1. They just give me the same answer, 5 or negative 5, depending on which order I put them in. And since for the distance between two numbers, I always want the positive version of that, I can define the distance between x and y to just be x minus y, instead of worrying about whether I put the bigger one first or the bigger one second, just put absolute value bars around it, and that's guaranteed to give me the positive version of this difference. So the distance between any two numbers is subtract them in whichever order. It actually doesn't matter which order, because whichever order I do it in, if I put absolute value around it, I get the positive version of that. No matter whether I got 5 or negative 5, I put absolute values around it and I get the answer, this distance here, of 5 between them. So absolute value comes up a lot in talking about the distances between things.